Namaskar, my dear friends. Welcome to the lecture series of computer-aided manufacturing. In our previous video, you will learn about the fundamentals of part programming, in which you will learn about the introduction of part programming, then different NC words used in the part programming, G code, M code, and format of the part programming. Okay. Now let us uh, discuss in this lecture, or let us solve the different problems of the part programming. Okay. So first, machining in point to point. Okay. So in this point to point CNC system, the workpiece or the cutting tool, it moves from one point to another point, and machining is done at the specific points, and no machining is done when the spindle or the workpiece is moving between the 2 points. Okay, so to understand the point to point machining, let us consider workpiece as shown in here in this figure. Okay, now here 3 holes are there, and diameter of all the 3 holes is 10 millimeter. Okay, and now you can see here total this length is 40 mm. Okay, and this is 60 mm. Okay, and this distance is 10 mm. This distance is 10 mm. Okay, so distance between these two hole is 40 mm. Okay, and distance between these two holes is 20 mm. Okay, this distance is 10 mm. This distance is also 10 mm. So distance between these two holes is 20 mm. Okay, now we have to drill the 5 mm hole depth. Okay, here, right. So for that, the depth of the hole is 5 mm. Okay, and Z is 0 0 at the surface of workpiece. Okay, at the surface of workpiece, the value of Z, okay, Z coordinate is 0 0, and the cutting tool is positioned above the workpiece surface. Okay, cutting tool is at the workpiece surface at here. Okay, now let us how to write the part program. So initially, first one is N010 is the sequence number. G71 is the metric mode. Okay, G90 is absolute system, and G94 is the feed in mm per minute. Okay, and T01 is tool number 1. Okay, and you can write here EOB, that means the end of block. Okay, now in second sequence, that is N020. M03, it means the spindle start clockwise. Okay, spindle start clockwise, M03. S800, that means the spindle speed is 800 RPM, revolution per minute. And feed F200, that means the feed rate is 200 mm per minute. Okay, feed rate is 200 mm per minute. And M08 means coolant on. Okay, coolant on. M08 means coolant on. Now here N030, it means, okay, here now G00, that means the rapid traverse. Okay, G00 means the rapid traverse, and X0, okay, Y0, that means we have to keep our tool at here at this point. At this point, this is X0, Y0, and Z5 mm. Z5 mm, this means, okay, the tool is 5 mm above the workpiece surface. Okay, So this is the rapid traverse. There is no cutting at this. Okay. Then next one. Okay. So next one is G00. Again rapid traverse. X10, Y10. Okay. X10, Y10. And Z remains same. Z remains the 5 mm. Now our tool is 5 mm above the workpiece. Okay. So now this tool will move from this 00 to here at the center. Okay. At the center of this hole. Okay, it will move at the center of this hole. So you can see X10 and Y10. Okay. And now tool will be here. So tool is above the 5 mm from the workpiece. Okay. Now linear interpolation. So linear interpolation G01 Z minus 5. Okay. Z minus 5. That means, okay, so the tool will come here. Okay, tool will come here and it will drill the 5 mm depth hole. Okay, so at 00, that means minus 5 means tool will come at 00, then it will goes inside 5 mm. એટલે કે ટૂલ છે અત્યારે 5 mm ઉપર છે એટલે ટોટલ ટૂલનું ટ્રાવેલ થશે 10 mm. ઓકે 10 mm એટલે કે ટૂલ 00 એટલે વર્કપીસને ટચ થશે અને -5 mm અંદર જશે. ઓકે, so linear interpolation એટલે કે એ દરમિયાન it will cut the material. That means machining will start. Okay, then next is the rapid traverse Z5. Now tool will goes upward 5 mm. Okay, tool છે 5 mm ઉપરની ડાયરેક્શનમાં જશે. Okay, then so now here the completion of this hole number 1. Okay, completion of hole number 1. Now from the rapid traverse it will come x50. That means y remains constant. Okay, y remains constant. Now it will move from this hole to this hole. Okay, so our tool is at this center. Okay, tool is at the hole number 2. Okay, then again G01 Z minus 5. So it will drill the hole for 5 mm. Okay, then again G00 rapid traverse and tool will goes upward. Okay, 5 mm from the surface of the workpiece. Okay, then rapid traverse, now it will move from here to here. Okay, from hole number 2 to hole number 3. Okay, so that distance is 30 mm. Why 30? That means from here to here. Okay, so this distance of this hole, okay, is 30 mm. So why 30? Okay, then linear interpolation G01, okay, and Z minus 5. Z minus 5. Okay, so it will drill the hole. Okay, drill hole number 3. Then G00 Z5 tool will goes upward. Okay, then G99, okay, M02 spindle stop. Okay, then coolant off. Okay, coolant off and M05. Okay, so by this way you can drill the hole. Okay, spindle stop M05 is the spindle stop and M02 is the program stop and M09 is the coolant off. Okay, so by this way you can drill the hole. That is the example of the machining in point to point. Okay, now let us understand one more example, that is the lathe operation. So part programming for turning. So turn the diameter 26 mm. Okay, now you can see here you can see a component whose diameter is 30 mm. Okay, and here this length is 60 mm. Okay, so in case of the CNC lathe operations, only two axes, okay, x-axis and z-axis are involved. So the z-axis is the axis of spindle and x-axis is the direction of transverse motion of the tool post. So here in this case we can say this axis is a z-axis. Okay, this is the z-axis, okay, in this direction, and this axis is x-axis. Okay, it is the x-axis. Okay, so only two axes are there, okay, z and x. So to develop this CNC part program for the lathe operation, the procedure, okay, let us understand by this example. So groove the cutting tool. First is the move the cutting tool to a point near the job in the rapid mode G00. Okay, tool ne આપણે job ની નજીક લઈ જઈશું rapid mode માં, and then set linear interpolation G01 and move to the required depth of cut in X direction. Okay, required depth of cut in X direction. Then move along the z-axis to the required length. બરાબર છે, અહીંયા તમે આ ડેપ્થ ઓફ કટ લઈને પછી આ ડાયરેક્શનમાં તમે આને આપણે મૂવ કરીશું z ડાયરેક્શનમાં. Then set rapid mode G00 and retract the tool along the x-axis and move to the start point in G00 mode. Okay, so here there are two operations. One is the facing operation, and second one is to reduce the diameter of bar from 30 mm to 26 mm. Okay, first one is the facing operation. That means the operation performed on this surface. Okay, operation performed on this surface, and then second one is the to reduce the diameter from 30 to 26 mm. Okay, now let us understand. So as usual, G71, okay, metric mode, G90 absolute, G94 feed in mm per minute, okay, and tool number 1. Then M03 is the spindle, okay, then S800, F200, M08 coolant on. Okay, now initially G00, then X0, Z5. That means the tool is at the 5 mm from this. Here initially this point is the 00 point. Okay, initially this point is the 00. So our tool will be here at 5 mm Z and X is 00. Okay, now G00 X28. Okay, so X28, that means we have to take the depth of cut is equal to 1 mm. Okay, so from here actual this distance is 14 mm. So we have to keep this 14 mm, એટલે કે 14 mm જેટલું આ ડિસ્ટન્સ આવશે. એટલે અહીંયા આપણે ડેપ્થ ઓફ કટ 1 mm નો લઈશું, એટલે એનો ડાયામીટર આપણે 28 કરવાનું છે. એટલા માટે અહીંયા આપણે x કોઓર્ડિનેટ આપણે 28 લઈશું. ઓકે, x કોઓર્ડિનેટ 28. Then linear interpolation z minus 60, એટલે હવે અહીંથી 1 mm નો ડેપ્થ ઓફ કટ લઈ અને અહીંયાથી ટૂલ છે આપણું એ આ ડાયરેક્શનમાં 60 mm સુધી મૂવ થશે. Okay, so now our diameter becomes 28 mm. Okay, diameter becomes 28 mm. Okay, then again from G00 and Z0, okay, X remains common. Now rapid transverse. So now tool will move from here to here. Okay, tool will move from here to here. Now again linear interpolation and take one more depth of cut, so 26 mm. Okay, so now tool will start from here. Okay, it will start from here. Okay, so Z minus 60, so another depth of cut, so it will cut the material like this. Okay, so Z minus 60. Okay, again then rapid traverse 0 0, okay, G00 and Z0. So હવે તમે જોશો કે આમાં આપણે જે ડાયામીટર જે જોઈએ છે 26 mm નો, એ 26 mm નો ડાયામીટર આપણને મળી જાય છે. ઓકે, then G99, okay, M02 program stop, M05 spindle stop, and M09 coolant off. Okay, so by this way we can create a part program for the lathe operation. Okay, now let us understand next taper turning in linear interpolation. Okay, taper turning in linear interpolation. So part programming for turning in system. So raw material is a 20 mm facing. Okay, so we have to make the 20 mm facing. Okay, so this diameter is 20 mm, this diameter is 15 mm. Okay, and here is the 15 mm, this distance is 15 mm. So 15 mm taper turning, right? So in this case the G01 code is used for the taper turning also, because the taper turning is also machining along a straight line at an angle, so simultaneous motion of X and Z. Okay, in case of taper turning the simultaneous motion is required along both X and Z axis. So the part programming for taper turning operation is similar to the simple turning operation. Okay, so except that in case both the coordinates, that is X and Z values of the final point are to be given in the program. Okay, so now let us understand. So first operation is the facing. Okay, so we have to face this surface. Okay, then turn the 15 mm diameter over the 15 mm length. Okay, so we have to turn the 15 mm diameter, this is the 15 mm diameter, up to the 15 mm length. Then taper turning for the remaining 15 mm. Okay, now let us understand this example. So as usual, G71, G90, G94 and T01. Okay, so M03, S800, F200, M08. Now here G00, X0, so it will be here. Our 00 point is here. Okay, and Z5, so tool will be here 5 mm away from here. So okay, so initially tool will be here. Okay, now G00, X20, that means the tool will move, okay, in this direction for the facing in rapid traverse. Okay, in rapid traverse. And now here G01 linear interpolation for the 35 mm. Okay, for the 35 mm length. So the tool will move from here to here 35 mm, minus 35 mm. Okay, then G00, Z0. Okay, now let us take the first cut. Okay, X17, that means here 20 we have taking the 1.5 mm depth of cut. Okay, 1.5 mm depth of cut, that is the, so now diameter becomes 20 to 17. Okay, so up to the 15 mm, so Z minus 15, so tool will travel from here to here. Okay, then after completing that cut, again G00, Z0. Okay, again G01, X15. Okay, so one more cut, okay, of 1.5. Okay, so X15 and Z minus 15. Okay, so now this diameter becomes 15 mm from 20. હવે આ diameter છે એ 20 માંથી 15 mm નો થઈ ગયો અહીંયા સુધીમાં. ઓકે, હવે આપણે ટેપર ટર્નિંગ કરવાનું છે. એટલે ટેપર ટર્નિંગ that means કે simultaneous motion. Okay, X and Z both simultaneous motion. Okay, so for that here G01, X is 20 and Z is minus 20. Okay, X is 20 and Z is minus 20. Minus 20, that means કે આપણે જેમ સ્પિન્ડલની નજીક જઈશું એ માઇનસ થશે અને સ્પિન્ડલથી દૂર જઈશું એ પ્લસ થશે એટલે કે આ ડાયરેક્શનમાં આપણે જવાનું છે. ઓકે, x20 z -20 એટલે કે આ 15 mm નું અપ છે એ ટેપર ટર્નિંગ થશે. ઓકે, so now end of program. So by this way you can perform the taper turning operation, okay, in linear interpolation. Now let us understand one more example, multi-pass turning operation. Okay, multi-pass turning operation. Here you can see one bar is there. Here the diameter is 20 mm. Here diameter is 16 mm and diameter is 12 mm. Okay, so part programming for the turning raw material, diameter 20 mm facing and step turning. So we have to make the diameter from 20 to 16 and 12. Okay, so first of all we have to face this surface 20 mm facing, 20 mm નું facing કરશું. પછી આપણે આ 20 mm થી 16 mm નો ડાયામીટર કરશું. આ જે લેન્થ છે એમાં 50 mm ની લેન્થમાં અને પછી 35 mm ની લેન્થમાં 12 mm નો ડાયામીટર કરશું. ઓકે, એટલે આપણો જે 00 પોઈન્ટ છે એ આ જગ્યા ઉપર 00 પોઈન્ટ છે. ઓકે, so initially as usual G71, G90, G94 and T01. M03 spindle start, speed 800, feed 200, M08 coolant on. Okay, now initially G00 X0 is here and Z is 5. Okay, now rapid traverse Z00, that means the tool will be here. Okay, now initially first G01 X20, okay, then G01 Z50. Okay, so from here it will travel up to this distance 50 mm. Okay, here it is not a 28 but it's 18. Okay, it's 18. So first part is okay, first, so now make the diameter is 18 mm. Okay, diameter is equal to 18 mm. Then repeat the same procedure for this 50 mm length and make the diameter is equal to 16 mm. Okay, make this diameter is equal to 16 mm. So now here this job becomes 16 mm diameter for this particular 50 mm length. એટલે કે અહીંથી આ જે લેન્થ છે એમાં ટોટલી ડાયામીટર હવે આપણે 50 mm નો ડાયામીટર થઈ ગયો છે. ઓકે, હવે આપણે આ જે 35 mm માં આપણે 12 mm ડાયામીટર કરશું. Okay, now we have to make a diameter of 12 mm. Okay, so for that rapid traverse G00 Z0 and G01 X14. Now make the diameter from 16 to 14, 1 mm depth of cut, and the Z is -35, so up to here. Okay, -35. Then again X12. Okay, so diameter becomes 12 mm, G01 Z -35. Okay, so this is the step turning. Then G99, M02, M05 and M09. Okay, so by this way, okay, you can make the part program for multi-pass turning operation. Okay, now machining using the circular interpolation. Okay, circular interpolation. So for this circular interpolation, okay, it can be produced on CNC lathe using G02 or G03 code. Okay, so in addition to X and Z values, the parameter for center of the arc are also given in the program with I and K words. Okay, so I and K denotes the center of the arc for circular profile. Okay, so to understand the use of circular interpolation function, let us see one example here. Okay, so this diameter is 20 mm. Okay, now here you can see the circular interpolation. The radius is 5 mm here. Okay, and this distance is 10 mm. This distance is 5 mm. Okay, so first is a G90, G71, G94 end of block. Okay, then G00X00 Z1. Okay, we keep the tool at 1 mm from this here. Okay, then G01 Z0. Okay, so now tool will be touch here and the block. Now circular interpolation clockwise. It will start from the here. Circular interpolation clockwise X 10 mm. Z minus 5 mm. Okay, X10, Z minus 5, I0, K5, feed 150 and the block. Okay, so X value is 10 mm, right? So it will start from the here. Okay, and Z is minus 5. Okay, so Z value is minus 5 from here, minus 5. I00 and K is equal to 5. That is the is equal to 5 Z. Okay, so circular interpolation. Then N05 G01 Z minus 15. Okay, Z minus 15. That means this distance is minus 15 and the block. Again X20 Z minus 20 I5. Okay, I5 K0 and end of block. Okay, then M02 end of block. So by using I and K, okay, circular interpolation by using the code G02, okay, and G03, you can make the part programming for the circular interpolation. Okay, so now I hope you can understand how to prepare the part program for the CNC. Okay, and in our next lecture, we will learn about the cutter radius compensation, then subroutine, do loop, can cycles, then 0 point and reference points. Okay, so thank you very much.